Namaste. I, Jv'n Neha Sharma, JVWU University Department of Science and Technology, Faculty of Education and Methodology. So in last lecture, we studied data link layer functions and the issues related to data link layer. And in those issues, we also learned about the error control. Right? So basically, in this lecture, we are studying the error control in detail with different protocols associated with the error control. So what is error control? So error control in data link layer is the process of detecting and correcting data frames and the data frames that have been corrupted or lost during transmission. So in case of lost or corrupted frames, if the receiver doesn't receive the correct data frame, okay, if the receiver doesn't receive the correct data frame and sender is ignorant about the loss, the data link layer follow a technique to detect transit errors and take necessary action. Is retransmission of frame. Whenever error is detected or frame is lost, the process is called automatic request (ARQ). Okay, so basically, data link layer in data link layer, the error control functionality is all about detecting and correcting the data frames with errors, right? And transmitting it from source to destination, error-free and reliable data, right? So there are no frames are lost in between the source and the receiver. There are no duplication in frames. There are no data loss in frames. There are no error bits in the frame, so that the data is changed, right, in between source and receiver. So it ensures that the receiver only receive the frames which are reliable, accurate, and error free, and there are no duplicate frames that has to be transmitted to the receiver. So phases in error control is detection of error. If it is detected by either the sender or the receiver's acknowledgement, either positive or negative. If it is positive acknowledgement, then it is identified by ACK. If it is negative acknowledgement, then it is identified by NACK. And on receiving a damaged frame or a duplicate frame, the receiver sender negative acknowledgement back to the sender. In retransmission, the sender maintain a clock and a set out time period. So if an acknowledgement of the data frame previously transmitted doesn't arrive before the timeout, or a negative acknowledgement is received, then sender retransmit that frame. Okay, so this is called what about the retransmission of the data frames. So here we can now study sliding window protocol. So sliding window protocol are data link layer protocol for the reliability and sequential delivery of data frames. Okay, basically reliable and sequential delivery because frame synchronization is always matter than it is the matter of transmission of data. If the wrong sequence data is delivered, right, from source to receiver, then the meaning of data is might be changed, right? So it is always important that the data frames are sent from source to receiver is in sequence. Okay, so sliding window protocol ensure that sequential and reliable delivery of data frames. And the sliding window is also used the TCP protocol. In this protocol, multiple frames can be sent via sender at time before receiving an acknowledgement from the receiver. The term sliding window is basically imaginary boxes to hold frames. Sliding window method is also known as windowing. So in which principle the sliding window protocol exactly works? So let's see. In this protocol, the sender has a buffer called a sending window and receiver has a buffer called receiver window. Okay, so this is a window of sender and this is a window of receiver. So the size of sending window determines the sequence of the outbound frame. If the sequence number of the frame is an AND bit, then the range of sequence number that can be assigned is 0 to 2 the power n minus 1. So consequently, the size of sliding window is 2 the power n minus 1, and this is ordered to accommodate a sending window size of 2 the power n minus 1. A n bit sequence number is chosen. So here we see we take a sequence, numbers are in as a modulo and. So for example, if the standing window size is 4, so the sequence number will be 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and so on, because standing window size is 4. And the number of bit in the sequence number is 2 to generate the binary sequence. So basically it is for 0, 0, 0, 1, 1, 0, and 1. So the size of receiving window is maximum number of frame that the receiver can accept at a time. So it determines the maximum number of frame that the sender can send before receiving acknowledgement. Okay. So for example, here we take a sender and receiver window, each of size 4. Okay, sender window and receiver window both have size 4. So the sequence numbering of both the frames will be, both the windows will be 0, 1, 2, 3, 0, 1, 2, 3, and then so on. Okay, so basically frames are divided into 4 bits, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and then so on, right? So here you can see in the below diagram, here the frames are numbered as 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, right? So as we take the sending window size and the receiving window size is 4. So sliding window is stacked at 0, 1, 2, 3, 4, and equal to 4 and equal to 4. Okay. So why this protocol is called sliding window, because the window is slide, then the number of frame is sent, and receiver window get sent back the acknowledgement that okay, I received these frames. Then the window is slided to the right and take again the uh, 4 frames, right? So then again it takes 0, 1, 2, 3, right? And again send it to the receiver. Then again slide it when acknowledgement received. Then again slide the window slide to the right, and again then send the data to the receiver, send the frame to the receiver, and get acknowledged. Then again slide the window 1 bit. Okay, स्लाइड द विंडो 1 और 2 बिट, जितनी उसे एक्नॉलेज मिलेगी जितनी फ्रेंड्स की, वो उतना उससे आगे स्लाइड कर जाएगा. जैसे कि यहाँ पे अगर हम देखें तो फर्स्ट में 0, 1, 2, 3, राइट? तो फ्रेम साइज इज बिकॉज ऑफ 0, 1, 2, 3, बट इट एग्जैक्टली ट्रांसमिट ओनली 2 फ्रेम, 0, 1 and 2, 0 and 1. So 0, here you can see on the arrow frame 0 and 1 sent. Okay. So here sending window sent only 2 frames, 0 and 1, and then get acknowledgement 2. So basically this 2 is defined here, the number of frames the receiver received. So right now receiver received 0 and 1, so acknowledgement 2 received. A message is received to the sending window by the receiver. So here you can see 0, 1, 0 and 1. The window is slide till 2, because 0 and 1 is already received by the receiver. So the sliding window slide to the right. Okay, and then sending the next frame. So here you can see receiver sliding window send only frame 2. So it slides. Then it gets the acknowledgement 3 and slides the window to 0, 3, 0, 1, 2, because sending window size is what? Sending window size is 4 and receiving window size is also 4. So now the sliding window is again set. Now if you want to send the frames at a one go, then you can also send it like 3, 0, 1, 2 sent to the receiving window, then you get acknowledgement 4. Okay, so 4 means this receiving window received 3012 the whole data. Then window is again sliding to the next 3012 and so on until it is completed. So this is all about the sliding window protocol. Here the window is sliding to the right after it get the acknowledgement of the frames the receiver sends to the receiver. Okay, so this is all about the sliding window, and there are different type of sliding window protocols based on the ARP, automatic repeat request. It is Automatic repeat request is a group of error control protocol for transmission of data over noisy or unreliable communication network. These protocols reside in data link layer and the transport layer of OSI model. So they are named because they provide automatic retransmission of frames that are corrupted or lost during transmission. So ARQ is also called positive acknowledgement with retransmission PAR. ARQ are used to provide reliable transmission over unreliable upper layer services. They are often used in GSM communication. So the working principle of ARQ is basically what? In this protocol, the receiver sends an acknowledgement message back to the sender if it receives the frame correctly. And if sender doesn't receive the acknowledgement of a transmit frame before a specific period of time, or to say time of occur. The sender understands that frame has been corrupted or lost during transit, and then automatically the sender retransmit the frame. The process is repeated until correct frame is transmitted. So via ARQ, we also fulfill the criteria of synchronization of frames because no frames are transmit out of order because of the synchronization. Because in this, receiver get the acknowledgement of each and every frame, and there is also a clock associated with it. So if the on a particular specified time you didn't get the acknowledgement back to the receiver, then it is assumed that the frame has been corrupted and lost, and then sender retransmit the frame. So again, it is the data received by the receiver is in sync. Okay, so the type of ARQ protocols, there are three type of ARQ protocols: stop and wait ARQ, go back and ARQ, selective repeat ARQ. In stop and wait ARQ, provide unidirectional data transmission with flow control and error control mechanism appropriate for noisy channel. The sender keep a copy of the sent frame, and it then wait for a finite time to receive a positive acknowledgement from the receiver. If time expires, then the frame is retransmitted. If a positive acknowledgement is received, then the next frame is sent. So we can also learn these protocols, ARQ protocols, in detail in next lectures. This is just about the overview of about these ARQ protocols. And next is go back and ARQ. Go back and ARQ provide for sending multiple frames before receiving the acknowledgement for the first frame. So it uses the concept of sliding window basically. So if the frames are sequentially numbered and the finite number of frames are sent, if the acknowledgement of frame is not received within the time of period, then all frames starting from the frame are retransmitted. Like for example, there's a we can say that we can take the example above. Uh, Sliding window sending and the receiver window size is 4. So 0123 0123. I send the whole data frame in a one row, 0123, right? And then slide the window to the right. Again, set to 0123. Okay, then again send 0123 before getting acknowledgement. But if timeout occurred and I didn't get acknowledgement from the receiver, then again the whole sliding window again slide to that frame, and then again 0123 retransmitted to the receiver until it get. Okay, and again we get the acknowledgement. Okay, so this is all about go back and ARQ. And in selective repeat, the protocol also provide for sending multiple frames before receiving the acknowledgement for the first frame. So here only error or lost frame are transmitted, while the good frames are received and buffered. Okay, so this is all about the sliding window protocol and different ARQ protocols, which we are also studying in detail in the next lectures, and all about the error control mechanism of data link layer. So yeah, that's it, and thank you so much.